Oh, hi folks. Yep, it's definitely working. See these video recordings. This technology. I ain't technical, Tommy, as you know. But anyway, let's talk about algebraic fractions. So that is, we're going to look at what happens between fractions. And we call them basic operations, which are add, subtract, multiply, divide. You could have sine, cosine, square roots. They are operations as well that act on certain things. But we are dealing with fractions. So, as I said, for example, e.g., that there could be that there, that there, that there. Please notice the middle sections between them. Add, subtract, multiply, divide. That's what I was just talking about there. How do we come up with the results? Well, as it says, it might not be obvious how we get to these answers, but to make it a wee bit clearer, we'll just use numbers for the fractions. So, a third and a third, 5 over 7 take over 2 over 7, 9 over 10 take over 3 over 10, 4 over 1 plus 2 over 11. If you're in one of my classes, some people shout out the answers, and you might have shouted out that there, 2/3, 3 sevens. You might have shouted 6 over 10th, and then somebody might have said, oh no, Tommy, that's not right. I can simplify that. Well, you're quite right. Because both top and bottom were divisible by 2. And last one, fine. What did they all have in common? Yeah? What did they all have in common? Those 4. The bottom numbers were all the same. Some people call them the denominators. I'll just call them the bottom numbers. This one, half and a third. I get responses like 2/5. That's a common response I get. That's fine. What about this one? Poof, jinx. That's too difficult. No deal with that one. Not deal with that one yet. But let's deal with this one. A half and a third. Let's deal with this a different way. Let's think of it. Well, is that circles? Aye. Half a circle and a third of a circle. Or pizzas, whatever you might think of it. And if I join them together, oof, can't quite make that out. I'll try to grid these up. It looks like I've divided each part, the half into 6 and the third into 6s. So I've got 1, 2, 3, 4, 5. And it looks like I've got 1, 2, 3, 4, 5 out of 6. So is that the answer? Oof, I don't know. No, I do know. That is the answer. But without one, pizzas or pies or circles, here's a better way of doing it. There are different ways of doing this. And it's because I'm in front of you or behind the TV screen, the app that you're listening to whatever you want to call it. This is my method. So you get a fraction, a over b plus c over d. This will be and this is actually for adding and subtracting. Okay, we just add. What's for subtracting as well? So take the bottom parts, multiply them together. That's fine. Take the right hand side, take it up to the opposite diagonal, multiply them together. And finally, take the bottom left hand corner up to the right hand corner, top, and multiply. So that's the instructions. Bottoms together, bottoms up and across. Bottoms together, bottoms up and across. Bottoms together, bottoms up and across. That's it. That's your answer. And maybe later on things you'll be like tinker about with things and sort it out. But for now that's fine. Let's see if it works with numbers. Bottoms together and take the addition from the top, put it in the top part of the fraction. Up, across, up and across. That's the rules. Let's see if it works. 3 1s, 2 1s, 2 3s. And at the top's 5 6. That seemed to work. That represented like the pizza thing. There you go. Oh, can we do the hard one? 7 13s on the bottom. What's that, 91? 13 times 2. What's that, 26? 7 3s, 21. As indeed. Add them together. I don't think top and bottom will cancel. Because 47 is a prime number. But you can look into that yourself. But the rule seems to work. Oh, now we'll get letters. What was this? Let's just tie bottoms together. Up and across diagonally. 12 from the bottom. So 4 from the right bottom comes up to the x to get 4x. 3 from the bottom left comes up to the x to get 3x. And can you tinker about with it? The top, 4x and 3x, what would that give you? 4 of something and 3 of the same something? 7 of something, x. And look at the 7 and 12. Can you find a number that divides into them apart from 1? I don't think so. Done. Right, okay. Let's go for this one. There's my row in place. Bottoms together, diagonals up and across. It's a minus this time between them, so I'm subtracting 2 3s are 6. 3x on the left will give me 3x. 2 times x on the right give me 2x. 3x to give me 2x. One lot of x. You could write it as 1x or just x or 6. That looks fine. Or a 6 of x. That's fine. Because dividing by 6 is just the same as taking a 6 of something. Oh, what was this one here? 2x to give 3x. Right, if you want to employ the rule that I've just given you, x times x, x squared, x times 2 is 2x equals 3x, could have done that, negative x under x squared, oof, negative 1 over x, I cancelled an x, top and bottom, that you're confused about, or negative 1 over x, but you know what, I wouldn't have done that. because I haven't looked at the bottom parts here. They are both the same. So I just said 2 take of 3 over x. It's negative 1 over x. But I took that negative out the front because it's overall negative 1 over x. Bang! I hate when people put in this, especially as a quiz. That makes you think. What's the quiz? A half times a half. Right, I get various answers to this. A half times a half. One of the answers is 2, and one of the answers is 1. But I actually do get the right answer for some people. But this is a better question. What's a half of a half? And then people start to think, right, I know what half of a half is. A half of a half, that's a half of something. And then if I half it again, I get that. And then they think, well, I know what that is. That's a quarter. Is that not what it is? That's a quarter. Well, let's move on. What's a half times a third? Right. Oh, pizza time. Half time, they're meant to be thirds. That's meant to be a third, that's meant to be a third, and that's meant to be a third. But I'm going to try and make it even easier for you. See, a half times a third is actually maybe just one part out of the 6. We'll come back to that. But here's the rule for multiplying. If you're multiplying, this is the easiest rule with fractions. If you're multiplying, all you do is take the top, multiply them together, take the bottoms, multiply them together. And that's all you get. That's it. AC in the top, DD in the bottom. Doesn't matter what alphabetical order you put them in, that's fine. Right, okay, let's go for this one. X over 2 times x over 3. We're multiplying here. So top times the top, bottom times the bottom. So x times x, 2 times 3. X squared over 6. That's it. Nothing can simplify top and bottom. Done. This one here, or there's more things involved. There's various ways we can deal with that. Why don't we just multiply the tops together and the bottoms together? So 9x times 20, what's that, 180x, and downstairs 15x, down there. And what we're looking at, right, we've got numbers top and bottom, they can divide x over x. X divided by x is just 1, but will get absorbed into the result of 180 divided by 15. That'll just give you 12. Right, last rule, division. A half divided by an 8. What are they asking here? How many 8ths can you get out of a half? That's what they're really asking. Don't think pizzas, but you can think of pizzas if you want. How many 8ths can you get out of a half? That's half divided by 8. Because if it was 10 divided by 2, how many 2's can you get a 10? How many 2's can you get a 10? Maybe there's 5? Right. Okay. So how many 8ths can you get out of a half? So we'll get 8 of them. We'll get 8 8ths. But how many can we get out of a half? 1, 2, 3, 4. You okay with that? Right, so here, without drawing pizzas or pies, whatever, here's the rule. To get a fraction divided by a fraction, we don't like division with fractions, so what we do, we keep the first fraction, instead of dividing, we just multiply. But we can't just do that. So what we have to do here, we can't just go from divide to multiply. So there has to be something else that goes on. What we have to do is the reverse of the inverse of multiply. So see the top fraction, it gets flipped. So that's a compensation factor. It goes divide into multiply, then the second fraction, we just flip that. Right. Sometimes you just need to accept things. Do you accept it? I don't know. Well, let's see if it works. And then, so like it's in there, take the divide to multiply and flip the second fraction and see if it works. And then multiply the top two, multiply the bottom two, and then you've got your result. So let's see if it works for this. So I think we've seen from the pizza example, there's 4 8s within a half. Does it work? After by 8/1. We flipped it. We flipped the second one. Is that too quick? We kept the half the same. Divide became multiply, but the 1 over 8 become 8/1. Right. Now we can do 1 times 8 and 2 times 1. 8/2. Let's 8 divided by 2. I think that's 4. And that seems to work. Jings. Let's see if it works when we look at letters. X/7 divided by X/6. Let's flip the second fraction. 6 times X over 7 times X. 6/8, 7 times X. And you notice, see you've got an X top, X, but they can cancel because X divided by X is actually 1. So we should just end up with 6/7. Correct. And for now, folks, for algebraic fractions, I am finished. That was a wee quick lesson. Good. But make sure you go through all the questions that you've got and all your exercises.